Hi, my name is Katie and I'm the driver for the session and I'm here with.
Hi, my name is Bonnie. I'll be navigating this session.
So today we are going to cover chapter 10, Numbers Method. Summary of this chapter. This chapter shows how Java helps you work with numbers beyond basic math. You'll learn how to run numbers to get absolute values and compare them. Format numbers with decimals or commas. Convert between strings and numbers. Use collections like array lists that need number objects like integer not int. Understand static methods and static final constant tools that belong to a class, not an object. It's all about making numbers easier to use, display, and manage in real world Java programs. So here we have page 277. The difference between regular, which is non-static, and static methods. So Java is all about objects, but sometimes you don't need an object to do something. That's where static methods come in. So what is a regular non-static method? It belongs to an object, it needs an object to run, and can use its object data called instance variables. So take a look at the example that we have. So here, play depends on the song title, so you need an object to use it. So next we're going to cover what is static methods. So static methods belong to a class, not an object, doesn't need any objects to run, works the same every time, no instant data involved. So next we have another example. So here in this example, we I didn't create a math object, just use the class directly, which is the .min. Doesn't care about any internal state, it just does its job. So a quick analogy. So the regular method is like asking your friend to play their favorite song. It depends on who they are. And then the static method is like asking a calculator to find the smallest number, but you don't care who's asking. So why it matters? Use regular methods when behavior depends on an object. Use static methods for general purpose tools like math, formatting, conversions. Next we have page 279. So static methods versus instant variables. In Java, static methods belong to the class, not any specific object. That means they can't access instant variables because they don't know which object data to use. If you try to use an instance variable like size inside a static method like main, Java throws an error. Non-static variables cannot be referenced from a static context. Why? Because there might be many dark objects or any objects in general, and the static method doesn't know which one size you mean. Um, so we can fix it by creating an object. So look at this example that I have over here. So I'll just go line by line. So here we have duck d equal to here we have duck d equal to new duck. So here we're creating a new duck object and naming it d. So think of it like saying, hey Java, give me a duck I can work with. Next we have the dot set size 42. Give me a second. So you're telling your duck your size is 42. So this calls the set size method, which stores the number 42 inside the duck size variable. Next we have our system output print line. Here we're asking the duck what is your size. Then the get size method returns 42 in Java prints the size of the duck is 42. So here we are using many methods. So Here we're creating the object called duck, and then we're naming the duck D, and then we um using a method called set size. So we want to set the size of the duck to 42. And then in this variable over here. And then next we are asking Java um to get the size. So we're using the get size method over here to get the size of the duck. So all these methods work to tell us that the size of the duck is 42. So we're setting the size. So here we're using the set and get method. So here we set the size to 42, and now it's getting the size from the set, which will be 42, and the output will obviously be the size of the duck is 42. Next, we're moving to math methods. So this part introduces some handy static methods from Java math class tools you can use without creating any objects. So here we have our math methods that I will now go into. So here we have math absolute, which is math.abs. So this just returns the absolute value, which will always be positive and works with the int, double, etc. Here we have an example. So here we have int x equal to math.s negative 42. This will return a positive um, value, which will be positive 242, because it said that it will the absolute always returns a positive value. Next we have double D method.apps 240.45. As it was stated earlier, it does work with doubles and integers, so that will obviously work. Next we have method random. So method random returns double between 0 and 0, which is inclusive, and 1 plus 0, which is exclusive. So you can scale it to get random integers. So here we have double R1 equal to method random int R2, which is method random times 5. So basically it's 0 to 4. And then over here, but the double, it's 0 to 1, basically. Um, Next we have method round. We just highlighted. So here we have method round. So method round rounds the number to the nearest whole value. So if you pass it a float, it returns an integer. If you pass it a double, it returns a long. So here we have examples. So int x equal to method round, which is negative 24 0.8f. Thus will return a negative because it is rounding off. Next we have int y equal to method round 24.45. Thus will return 24. Next we have long z equal to method round. This is a double, so 24.45 will return 24L. Next we have method min. Just how do I do it like this? Sorry. Whatever. So there we have method min. So method min returns the smaller of two values. So it works within double float long. So let's take a look at examples. So here we have int x equal to method month 24, 240. So this will obviously return 24 because it returns the value of the minimum of the two arguments. Next we have double y equal to method min with our numbers of there, and that will return 49 because it does return the minimum number. Next we have math.max. So math.max returns the larger of two values, also overloaded in different types. So basically it will just return a value that's the maximum of the two arguments. Here we have examples. So in x equals to math.max 24, 240. So that's will obviously just return 240. And then we have a double y equal to math.max with our numbers over there, and it will return 12.5 because it returns the maximum of two values, which is the largest. Next we have method square root. Basically it returns the square root of a number that will always be positive. So it takes a double, um, but you can pass anything that fits in the double. So now we have our examples. So we have double x equal to math dot square root, which is 9. It will obviously return 3. Then we have double y math square root 42. So that's will return the decimal digits over there. So why it matters? So this just help you to clean up messy numbers, compare values easily, do basic math without writing your own logic. So now we are going on to wrapping primitives. So Java has primitive types like int, double character, etc. But some tools like ArrayList only work with objects, not primitives. To solve this, Java gives you a wrapper class that returns primitives into objects. So an int is an integer, a double is a double, a char is a character, and a boolean is a boolean, and so on. So why use wrapper classes? Because you can't do this. Like here we have an example. ArrayList int, sorry, ArrayList int list. This won't compile, but you can do this. ArrayList integer list equal to ArrayList that will obviously compile. Um, so now we are going to autoboxing. So Java does do the wrapping for you. So before Java 5, we had to manually wrap and unwrap values. So here we have int I equal to 288, integer I wrap, new integer that was manual boxing. Then we have the in unwrap I wrap int value that is the manual unboxing. Now Java does it automatically as we can see over here. Next. Autoboxing in Java. So autoboxing means that Java automatically converts between primitive types like int and boolean and their wrapper classes, which is the integer and boolean whenever needed. So you don't need so you don't have to do it manually anymore. Java handles the behind the scenes. So now we are going to go in way autoboxing works. Method arguments. So you can pass either primitive or wrapper type to a method. Like over here. So basically Java autoboxes 42 into an integer. Next, we have the return value. So you can return either a parameter for a wrapper, no matter what method expects. Sorry, no matter what the method expects. As we can see over here. Next, we have our Boolean expression. So you can use a Boolean object anywhere a Boolean is expected, like over here. Operations and numbers. So you can do math with wrapper like objects and integer, as it is done in this example over there. And now we have assignments. So you can assign parameters to wrapper variables and vice versa, like over there. So why is it cool? Auto boxing makes your code cleaner and easier to write. You can treat parameters and objects almost interchangeably, especially useful when working with collections like array list. Okay. So now we basically gonna go over turning numbers into strings in Java. So sometimes you want to convert a number into a string, maybe to show it to a user, included in a message or format like a currency. But Java gives you several ways to that. So here we have concatenation. So this is basically the basic conversion methods. Um, so we take a look over here at this example. We see we have string s equal to string plus t equal to 42.5. And then we have the so the plus operator is overloaded, basically adding anything to the string and returns it to the string. Next we have the double string. Um basically this works for other wrapper types too, like integer to string, boolean to string, etc. Next we have the string value of. This method works with any primitive objects that is super flexible. So formatting like money or with commas. So to format numbers with two decimal places, dollar signs, commas 4000, use the string format or system outprint format. So as we can see over here, we have double price over there. So string outprint format, and there we have it over there. Or we can use the decimal format. So import Java text decimal format. So here decimal formatter equal to new decimal. So this is a string formatted over there. Next we have number formatting in Java. Okay. So Java lets you format numbers into strings without relying on print statements. So this is especially useful when displaying numbers in GUIs, tables, or messages. So here we have our string format. It is a static method that lets you format numbers using special instructions like adding commas or decimal places. So as we can see over here, we have 1 billion. So we did add commas because it does allow us to format the numbers using special instructions. So we can also use underscores in large numbers, just like over here. So this just allows us to make big numbers look easier to read. As we can see, we have 1 billion and we separated it with the underscores to make it easy to read. Next, we have 297, formatting deconstructed. So Java's number formatting with string format or even system output format works by combining two parts. Formatting instructions. These are special codes inside a string that tell Java how to format the value. They always start with a percentage and include characters that describe the format. Here we have an example. So the percentage here comes a value, means basically the percentage means here comes a value. The comma is added for the thousands and the t is a format as a decimal integer. So now the argument. So this is the actual value you want to format. So it must match the type expected by the format code. So basically you can't pass in a dog or a random string. If the format expects a number, it has to be the right type. So think of it like you telling Java, here's how I want it to look. Um page 298. So here we have page 298. Um, so in Java, the percentage symbol inside a format string tell the formatter insert the value here and format it using instructions. So two parts of a string format. So here we have the first one. So this is the first argument and it includes literal text like I have or bugs to fix. And then the format specifiers like percentage 2f or percentage um 0.2f or percentage comma dot 2f values and formats. So this is the second argument, usually a number or something that matches the format specifier. So here we have an example. So let's just take a look at this example. Here we have percentage 2f. Let me just say it like this. So here we have string s and equals to string format. I have percentage dot 2f. This means the percentage here I'm inserting a value. The dot 2 shows the digits after the decimal, and then the f is the format as a floating point number. So add a comma for readability. So take a look over here. So we know what the percentage means. It's where we're inserting a value. The comma makes space for larger numbers. So and the 2f obviously just means the digits after the decimal and to format the floating point number. So here we're adding a comma for the thousands. They keep the two decimal in places. So here, take a look over there. The percentage is a placeholder with formatting tools and the value gets inserted and styled accordingly. So now it makes sense. So now we have page 299. We will break it down. So string format I have percentage 2f parts to fix with the decimal number over there. So this format string contains I have, which is a plain text, percentage dot to a format specifier, percentage I'm inserting a value, dot to show the digits after the decimal, and then the f format is a floating point number, and then the comma. Wait, is it a comma? What did I put in there? So the quote and the comma over there basically is bugs to fix, which is it's more plain text. See. So hopefully that makes sense. So I'll go over it again. Also to remind myself. So here we're taking a look at this example over here. I have is plain text, percentage dot to f is a format specifier. The percentage is where you're going to insert a value. The dot two shows the digits after the decimal. The f is a formatter for the floating point number. And then over here, from over here, this is just plain text. So now it formats this number over here is a floating point with two decimal places and then it appends the rest of the string. Then we will have an output like this. So notice that it is rounded to decimal places. In the comma, after the formatted number is just part of the string and it's not formatting, not a formatting instruction. So the key takeaways over here is percentage symbol, which kicks off the mini formatting language. Everything after it until the type specifier like FDS, etc., must follow the correct order. So flags like, oh, okay, let me just highlight it. Like over here, sorry, over here is for commas. The width is optional. The precision like 2, and then the type like FD, etc. So putting these things in the wrong order, like percentage D instead of percentage comma D, won't work as expected. Next, we have page 300. We just see how fast my battery. Let's see. Um, format. We my So format specifiers in Java. So when using the string format or the system output print format, you're just telling Java exactly how to format the value you inserting. So it starts with the percentage and ends with the type indicator like D, integer, or F, which is the floating point. So here we have the format specifier structure. So over here we'll take a look at the text. So only percentage and type are required. The rest are optional, but must appear in the exact order if used. So we're going to break down each part. Here we have the argument number. So basically, this just tells Java which argument to format if you have multiple. Next we have special formatting like commas left justifying or parentheses for negatives. Next we have the width, so a minimum number of characters used, pads if needed. Next we have the precision, sorry, the number of digits after the decimal point. And next we have our type. So it's basically a decimal integer, floating point, string, or a new line. So here we have an example. So basically this is format is a floating point, show which stands for the F, show one digit after the decimal, which is the dot one over here. Let me just get my mouse over here. Um, use at least 6 characters, which stands for the 6 over there, and insert commas if needed over there. Next, we have page 301. So we have our first example. Um, String format. So the goal is to format the number with 2 decimal places. So step by step, the original number over here. Dot 2f means round to the next 2 digits after the decimal. So Java rounds the number and then it looks at the third digit after the decimal, which will be 8. Since 8 is greater than 5, it rounds it off to the second digit, which is 9, and up. So it will obviously result to this number over here. Next, we have the string format. So the goal here is to format with commas to the next 2 decimal places. So the start, here we have the number. So the dot 2f round to the round 2 over here, same as above. And then the percentage, insert commas for thousands, and then the final result will be this. Example 3. So, example 3 is a hexadecimal. So, the goal is to format width of characters in one decimal place. So, step by step, if round 242 and the width 6, the result must take up at least 6 characters. 42 is only 4 characters, so Java adds 2 spaces in front, so the final result will be 42. Well, it's not an hexadecimal, sorry. Example 4, um, over here. So, string format, the goal is to format the hexadecimal. So, decimal 42, which is a x, equals to 2a. And then Java returns it by default as a lower 2a. Next, we have the string format. Format is a character, so Unicode character for decimal 42 is, and then Java converts the number and its matching character, and this will be the final result. Next, we have page 305, which is the last page. So now we just going to see static versus instant variables in the Java debate. So this section stages a humorous debate between two Java concepts, static variables and instant variables, each defending their roles in object-oriented programming. So instant variables. The, this belongs to an individual object. Each object has its own copy, represents object-specific state, ideal for true object-oriented design, criticize statics for being an OO, and much more like global variables, argue that overusing statics is a sign of poor design. Next, we have our static variables. They belong to a class and not many objects shared across all instances. Great for constant shared resources or utility access. Defend their usefulness in real-world APIs. Um, Highlight efficiency, one copy per class saves memory. Push back against the NOO label pointing out they still live inside classes. So the key takeaways for this is static variables are powerful and efficient when used wisely, especially for constants and shared tools. Instant variables are essential for modeling unique object behavior and state. Good design means knowing when to use each static isn't evil, but it's not a substitute for thoughtful object modeling. And that is it for chapter 10. Thank you for watching. 33 minutes.